The recording is started and I have shared my screen with you. If my voice is audible and screen is visible, give me a thumbs up in the chat box. Okay, great. Good. Good. So we are from the year. Okay. So these are the point or theory point that we are discussing. BIM horizontal structure member subjected to loading. Types of the beam: simply supported beam, cantilever beam, and continuous beam, overhang beam. These are the four basic types that we'll be looking for. Column: it is a vertical structural member subjected to loading. Types of the support: so roller support, hinge support, and fixed support. Loads: point load we have seen. Then uniformly distributed load. It is 1 minute change. No, it's okay. Point load is there. Point load is there. Uniformly distributed load is there. Uniformly varying load is there. So intensity of point load is F, given intensity. Intensity of uniformly distributed load is length into the intensity, and it acts at the distance of L by 2 at the center of the distance of the UDL. Then uniformly varying load, its intensity is nothing but the area under the triangle, that is half into length into width. It varies from minimum to maximum. The location of its intensity is from 2/3 of its length, and from maximum it is L by 3. That is nothing but it's the location of centroid that we have discussed. So here it is a test for you. Just look at the figure and tell me which type of the beam is this. Which type of the beam is this? You have to unmute it because I am unable to check meeting as it is good fit for the window. Please unmute and talk to me. Which type of the beam is this? How many types of the beam? Please unmute. Everybody, please unmute. Those who don't have any background voice, please unmute and talk to me.
Cantilever beam.
Perfectly correct. Which this is which type of the beam? This which type of the beam is this? Which type? Which type of the beam is this?
Cantilever.
Perfectly correct. Which type of the beam is this? Which type of the beam is this? One
Cantilever.
end is perfectly correct. One is fixed and one is free. Which type of the beam is this?
Continuous beam.
1, 2, 3, 4. If I focus on this and this for that first section, which type of the beam is this? First.
Simply supported. Simply
Perfectly correct.
support.
Very good. Very good. Which type of the beam is this?
Overhanging.
Perfectly correct. Which type of the beam is this? Which type of the beam is this? Which type of the beam is this? This is also overhang beam. It is hanging outside, na? So it is also overhang. Which type of the beam is this? Which type of the beam is this?
Overhanging.
Perfectly correct. It is a overhang. This is also overhang. This is also overhang. This is also overhang. This first section would be for that much. It is a simply supported beam. If you observe for complete, it is a continuous beam. Very good. Which type of the beam is this?
Continuous beam.
Perfectly correct. Continuous supports are there, so it is a continuous beam. Now here it is load. Which type of the load is this?
Point load.
Point load. Perfect. We are acting, force is acting at a point, so it is a point load. Which type of the load is this?
UDF.
Which type of the load? Perfectly correct. It is a UDL, uniformly distributed load. So the load of that pipe is uniformly distributed over the entire span, over the entire length of the trailer. Which type of the load is this? Talk about 3 meter distance. This is a first 3 meter.
Uniformly
It is a
varying.
uniformly.
Varying.
How it is uniformly varying? No. First, just tell me for first 3 meter. Tell me first 3 meter. It is a
UDL.
uniformly. It is a UDL, uniformly distributed, na? From A to this point, it is uniformly distributed. From this point to this point, second 3 meter, it is also UDL. From 1.5 meter, it is also UDL. So this is uniformly distributed load for first 3 meter of intensity 1.5 kilonewton per meter, for 1 kilonewton per meter for next 3 meter, and 1.5 meter it is having intensity 2.5 kilonewton per meter. Then now coming to the next point, that is shear force and bending moment. So what is shear force and what is bending moment? Try to understand. Just let's go to the word to word, and then I will tell you what does exactly mean of shear force and bending moment. At any section as shown in the figure B, at any section as shown in the figure B, at any section AA, this is section AA. At any section AA as shown in the figure B, this is the AA section. The net force to the left has to be equal in magnitude to the net force to the right, but in opposite in the direction of force of equilibrium. Means what? This is a AA section. If the summation of forces acting on the left hand side, this is the left hand side. If the summation of the forces acting on the left hand side is equal to the summation of the forces acting on the right hand side, both are same but opposite in magnitude. Okay, any section having the intensity of the forces on left hand side and the right hand side is same, but it is in opposite direction. If the net force to the left of the section in upward, then the net force to the right of the section is downward, it tends to shear off the beam at that section. If the intensity of the forces on the either hand is equal and opposite in direction, in that case, that forces lead to tend the beam to shear off. Means जर कुठल्याही सेक्शनच्या लेफ्ट हँड साईडला आणि कुठल्याही सेक्शनच्या राईट हँड साईडला the net force acting on the beam at left hand side and right hand side are same, but they are opposite in direction or opposite in magnitude. In that case, that forces will result to the shearing off of that particular beam. Shearing off means that force can fill that beam by shearing forces. So shearing force, say in C diagram, at left hand side forces, the force is downward, and the right hand side forces will be upward. Upward and downward means the magnitude is in opposite direction, but the intensity or the magnitude is same. That is V. VV is the intensity, but the sign in opposite direction. In that case, the beam will fill. So this is the left hand side beam. This is the right hand side beam. The point is, the point is, if any beam is in equilibrium condition, if any beam is in equilibrium condition, the summation of forces acting on any section at left hand side and right hand side are equal. The summation of the forces acting around any section in left hand side or right hand side are equal, but they are opposite in directions. Such a beam, if it is fail, it is said that the beam is fail due to shearing. Okay, next. Also, for equilibrium, the moment due to the forces or the moment due to all forces to the left of the section must be equal in magnitude but opposite in direction due to all the forces to the right of the section. The net moment due to all forces on the one side of the section is defined as the bending moment. It tends to bend the beam. Means as per the condition of equilibrium, in order to keep any beam in equilibrium position, there should be three different conditions that has to be satisfied by that particular beam. What are these conditions? The condition number one is summation of fx is equals to 0. What we have talked about right now, just shear forces, that is the summation of fy is equals to 0. And the third condition is summation of movement about any point is equals to 0. In the similar way as that of in the shear force diagram, the moment acting, the forces acting at the left hand side and the right hand side should be equal and opposite in direction that leads to the failure of that particular beam is called as a shearing off of that particular beam. In the similar way, if the summation of moment acting around any point at the left hand side and right hand side are always equals and that tends to bend that beam. If the moment acting on either left hand side or right hand side is considered, that moment leads to bend that particular beam, and the summation of moment on the beam which is in equilibrium condition is always equals to 0. The point is, if the forces acting on the beam, that forces tends to bend the beam, the moment or the forces acting to bend that beam is called as a bending moment. Okay, this will be very clear to you during the numericals. Type of support, just we have seen types of support, beam we have seen, loads we have seen, shearing force we have seen, the sign convention. Now sign convention for shear forces. This is a section on a beam. The forces acting on the left side of the beam is upward, and if the forces acting on the right side of the beam of the section is downward. If it is a section AA, and if some force act on the left hand side which is moving upward, what are its sign convention? And if a section acting on a beam, or if there is a section on a beam, and if the force is acting on the right side of the beam which is moving downward, so what about that sign convention? Sign convention means either it is positive or negative, that we have to look for. And similarly, if it is opposite, so if the section is there on the beam and the forces acting on the left hand side is moving downward, so what about its sign convention? If the forces acting on the right hand side and if it is moving in the upward direction, what we have to focus, what we have to consider, that we'll be looking for. All upward forces to the left of the section are considered as a positive, and downward forces are considered as a negative. If there is section, if there is section, all the forces acting, always we are always calculating from left hand side. So don't consider the right hand side side convention. Don't focus on this right hand side. Focus on left hand side only. Left hand side of the first, left hand side of A and left hand side of B. On the left hand side of A is upward forces and left hand side is a downward forces. All upward forces to the left of the section are considered as a positive and downward forces are negative. Whatever, if the forces are moving upward, just like uh, positive y-axis and negative y-axis. Forces are moving toward the positive y-axis, considered as a positive. Forces are moving toward the negative y-axis, considered as a negative force. Next, all downward forces to the right hand section is positive and upward as a negative. So most probably we are using only first type of the forces. So because we are calculating from the left hand side to right hand side. So the sign convention that we are utilizing is the forces moving upward is a positive and the forces moving toward the downward is a negative. Only the first type of the sign convention we are utilizing for the calculations. But that we must be aware of. So we have taken this too. Next, sign convention for bending moment. So just sagging and hogging concept is there. So what is sagging and what is hogging, that we'll be looking for. Similar to that of the sign convention of positive shear force and the negative shear force, that is upward forces are positive and downward forces are negative. In if it is in left hand side and vice versa for the right hand side case, the similar way there are sign conventions for the moments. So what are the sign conventions that we'll be looking for? Clockwise movement due to all forces to the left section are considered as a positive. Clockwise means what? See, this is the movement which is rotating in clockwise direction. This arrow is rotating in the clockwise direction. So we can say this is a clockwise movement. So the movement to the left side of the section is considered as a positive and anti-clockwise as a negative. So it is a clockwise, so it is positive. If it is anti-clockwise, so it is a negative. Anti-clockwise movement to the right of the section. So here it is an anti-clockwise movement. Right of the section is considered as a positive and clockwise as a negative. But we are mostly focused on the left hand side only. So we have to focus on clockwise movement is positive and anti-clockwise movement is a negative. If the clockwise movement is positive and anti-clockwise movement is also positive, and if it forms a sag, in that case it's said to be a sagging bending movement. So it bent like a cup, it form a bag. So here U shape. So this type of the bending movement is called as a sagging bending movement or positive bending movement. The positive bending movements on left hand side clockwise is a positive and right hand side is also positive. In that case it is said to be a sagging bending movement. And opposite to that, if left hand side bending moment anti-clockwise, it is taken as negative. Clockwise from the left hand side, it is taken as a negative. So both the cases we are living, we are not considering right now for the what are the forces and what are the moment acting on the right hand side. We are focusing on the forces acting on the left hand side only. I am repeating, forces acting on the left hand side. Whatever the forces acting on the left hand side, if the forces are moving upward, it is taken as a positive. If the forces are moving downward, it is taken as a negative. The clockwise movement at the left hand side section is taken as a positive, and the anti-clockwise movement at the section is taken as a negative. Okay, so just give me a quick feedback. Hold a second. Just give me a quick feedback. Upward forces are in the left hand side of the section. Upward forces are positive or negative. Upward forces are positive, Krishna. Downward forces are downward forces negative. Very good. Clockwise movement at the very good. Very good. So many answers are there. Very good. Clockwise movement. Clockwise movement in the left hand side of the section is positive or negative. Very good. Very good. So many answers are there. Nice. And very good, Sahil Dangi. Anti-clockwise movement in the Anti-clockwise movement in the left hand side of the section is positive or negative? Very good. Negative. Nilesh, Saurabh, Sahil. Very good. Nikam. Very good. Pratik. Where is Sheetal Jagtap? She is there or not? Sheetal Jagtap. Where is Sheetal Jagtap? Sheetal Jagtap, where are you? Anjali Sant, Divya Ahire, Kalyani Chauhan. You have to be active. Huh? Everybody has to be active. Negative. Very good. So it is very clear for everybody. We are calculating Kalyani. Very good. Hold a second. So right now it is very clear to everybody that the upward forces in the left hand side is a positive, downward forces are negative, clockwise movement is positive and anti-clockwise movement is negative. Very good. Keep in mind we are using that during calculations. Next. Simply supported beam. Simply supported beam. Simply supported beam of span L carrying a concentrated load at mid-span. Now, here we are just starting with the basics of numerical. But whenever we are calculating SFD and BMD, SFD and BMD calculations, steps, a very important point. SFD and BMD calculation steps. So what are the different steps we'll be looking for? First step is always a reaction calculations. First step is a reaction calculation. Second step is SF calculation. And the third step is BM calculations. Then SFD, that is shear force drawing. Then BMD, bending moment drawing. And next step is calculation of point of contraflexure, if any. Point of contraflexure. So this complete unit will revolve around only these 6 steps. 1 second. So this complete okay. So just read it and give me a steps orally in the chat box. Read this because the theory that I have right now conducted and these 6 steps, only these 6 steps will be 6 steps, and those few theory points are helpful to solve all type of the numerical in that unit. So just give me a answers in the chat box. What are the different steps required to calculate SFD and BMD? Everybody has to give the steps 1, 2, 3, 4, 5, 6, and you just give me the answers in the chat box. Fast, I'm waiting for a response from everybody. 6 steps are the very important steps. I'm expecting the steps in the chat box. Please give me steps in the chat box. What are the different steps required to calculate the SFD and BMD? Waiting for the answers. Only one answer is there. I'm expecting the other answers from everybody because that's very important. Everybody has to remember those steps by hook or crook. Everybody has to do the answers. Waiting for answers fast, everybody. Hello, very good. So, good. Reaction calculation, SF calculation, BM calculation, SFD. Huh. Reaction calculation, SF calculation, BM calculation, SF calculation, BM calculation, SFD, BMD, point of counterfacture, if any. Very good. So now it is very clear for everybody that you have to follow the steps. Good. Now moving next. Just have a simple understanding how to calculate the reaction, how to calculate SF, and how to calculate the SFD and BMD. Okay. Actually, that is not required. We can go directly for the numerical, but for the basics, we should. A simply supported beam of span L carrying a concentrated load at mid span. Okay. This is a simply supported beam. It is supported at point A and point B, and the W load is acting at the C. Right now, I told you there are different steps that we have to follow for the calculation. Any numerical in this unit, we have to follow that steps only. Okay. So if such numericals are there, so in that case, what are the different steps? I just told you, and everybody know that steps. So first step is the statement of the numerical is also same. Huh? The statement of the numerical is like calculate, draw SFD and BMD for the given loading diagram. That's it. Draw SFD and bending moment, SFD and BMD for the given loading diagram. That is the question for every question. The statement will be the same. The answer will be the same. You just have to follow the steps. Okay. The first step is reaction calculation. So reaction calculation, first step is the reaction calculation. In that case, we are going to apply the condition of equilibrium. That is summation of Fx equals to 0, summation of Fy equal to 0, and summation of moment about any point equal to 0. Okay. So here there is no forces acting along the x direction. So we are not focusing on the summation of Fx. So directly I am going to do the summation of Fy. Summation of Fy is equals to 0, the condition of equilibrium. So what are the different forces acting? This is a loading diagram and this is a free body diagram. Okay, so let us see. A is the support as it is, B is the support as it is, W is the load intensity, and it acts as a distance of L by 2. So it is L by 2, L by 2. So let's calculate the summation of Fy. RA is moving upward, RA is moving upward, so RA plus RB. What is going downward? W is going downward. So minus W. RA plus RB minus W is equals to 0. RA plus RB, RA plus RB minus W is equals to 0. RA plus RB minus W is equals to 0. That is nothing but RA plus RB is equals to W. From first equilibrium condition, we come to know RA plus RB is equals to W. This is a reaction calculation. We have applied summation of Fy. Now, okay. Hello, am I audible? Am I audible? आवाज येतोय माझा? Am I audible? Am I audible?
Yes, sir.
Okay, okay. Sorry, there is a net connection.
Yes, sir.
Light is continuously fluctuating, so there's the issue. Okay. My screen is visible to you. My screen is visible or not?
No.
Okay. Now it is. Now it is visible, na?
Yes, sir.
Good. So I'm here. So three different conditions of equilibrium. So summation of fx, we don't want that conditions. So we have not considered that. Summation of fy. I guess summation of fy is clear to everybody. Okay. Now third condition of equilibrium is summation of moment at any point is equal to 0, but I'm focusing on the summation of moment at A. When summation of moment at A I'm focusing, so I'm going to take a moment about point A. Okay. So moment is nothing but force into distance. Moment is nothing but force into distance. So let us consider the moment about every point. About A, W and distance between A and C is a L by 2. So W into L by 2. It is a clockwise movement. So W into L by 2. It is a W into L by 2. W into L by 2. Now here it is a clockwise. Now here it is a anti-clockwise. So RB minus RB into L minus RB into L is equals to 0. Focus on the moment I have taken. Okay. W is moving towards the A in clockwise direction. So here it is W into L by 2. That is plus W into L by 2. But RB is moving in the anti-clockwise direction. RB is moving in the anti-clockwise direction. So it is RB into total L. So RB into L is equals to 0. As summation of moment at any point is equals to 0. So just rearranging the term. So minus RB into L. So we are keeping that aside, so it will be RBL is a positive. So if we rearrange that term, we will be having the value of RB is equals to W by 2. If I put that W by 2 in that equation, there will be a RA is equals to W by 2 and RB is equals to W by 2. The point is, don't do that calculation. What I have done, try to understand these things, because we have to solve much numericals, but understanding is very important. What I'm going to do, what I'm performing the task, which way I'm doing this, you just try to understand these things. In first case, that is the reaction calculation, what I have done, I have applied the condition of equilibrium. What is the condition of equilibrium? Summation of fx is equals to 0, summation of fy is equals to 0, and summation of f of summation of moment about any point is equals to 0. So summation, I can write here, I can also write these things. Copy, and I can write these things too. Summation of fx, I can write summation of x is equals to 0. But there is no forces on x-axis. There is no force on the x-axis. There is no forces acting on the x-axis, so it is neglected. Along Fy, upward force is positive, downward force is negative. So Ra plus Rb minus W. And moment about A is a W into L by 2, distance, force into distance. Clockwise W into L by 2, and for anti-clockwise it is Rb into L. Just rearranging the term, as it acts at the center of the span, ultimately the load will act 50-50% on the either side. So that is W by 2 act on Ra and W by 2 act on the Rb. So this is what we have done for the step number 1. So I guess step number 1 is clear to everybody. If the step number 1 is clear to everybody, just give me a thumbs up in the chat box. If step number 1 is clear to everybody, please give me a thumbs up in the chat box. If step number 1 is clear to each one of you, then give me a thumbs up in the chat box. Okay. What about others? Chetan Jagtap, okay. Sonu Sansare, Nilesh Kuwar, Nutan, Ravi, Rani Bholap, Sahil. Okay. Step number 1 is clear. Huh? Here we are just orally discussing about what we are doing. Huh? In the next step or in the next numerical, I am actually conducting the numerical, and in that case, you have to solve those numericals. Okay, step number 1 is clear for everybody. Step number 2. Step number 2 is, what is step number 2? It is the reaction calculation. It is SF calculation. SF calculation. Now, whenever there is a SF calculation, we have to calculate shear force. SF means shear force. Now, whenever we are calculating shear forces, we have to calculate shear force on the left hand side of the each and every force. Left hand side and right hand side of the force. So here, most of the students are missing some why left hand side and why right hand side, but you are so talented. I guess nobody is asking me any doubt. I hope everybody is understanding, or everybody is either getting everything or you are not getting anything. Okay. So when there is a SF calculation, we have to calculate shear force at left hand side and right hand side of each and every point acting on the beam. Like shear force at left to the A. This is AL means left to the A. AR means right to the A. How many points are there? A, B and C. These 3 points are there. Shear force left to the A, shear force right to the A. Shear force left to the C, shear force right to the C. Shear force left to the B, shear force right to the B. These are the points. Now try to understand this. Why shear force at left to the A is equals to 0? Because at left of the A point there is nothing, there is no force. At left to the A there is no force. So the shear force is 0 at left to the A. There is nothing left to the A. So it is 0. Now shear force at right to the A. Right to the A means we have to put a section. We have to put means we have to consider a section over here, hypothetical section A, left to the right to the A. So what are the different forces? Right to them is right side of this section. Which force is acting on this side? Can anybody tell me which force is acting on this side, left hand side of this section? Can anybody tell me? Are you getting me? Sahil Dangi, Anjali Sant Nutan, Kalyani Bagul, Krishna, Saurabh Nikam, Jagtap, Sonu. Try to understand this. Huh? This is very important. Here I have drawn a section. In first case, what I have written, SF left to the A is 0. Everybody is agree with me? SF left to the A is equal to 0. Everybody is agree with me? Shear force left to the A is equal to 0. Anyone is agree with me? Yes or no? If anybody is agree with me, then just give me feedback. Yes, Sahil, thank you. Why? Sahil, my next question is why shear force left to the A is 0? Nikam Pratik, tell me why shear force left to the A is 0? Why shear force left to the A is 0? Sahil? Sahil. There is no force in the left of the A. Very good side. There is no force on the left hand side, so it is taken as a 0. Very good. Now listen. I have drawn a section at right side of the A, point A. And now from right hand side, what are the different forces are on the left hand side? Only RA is there. Only RA is there. So I am writing shear force at point right to the A is equal to RA is equals to W by 2. Because RA we have calculated, no? We have calculated these two parameters. We have calculated these parameters, huh? Okay. Try to focus on this section. I am repeating. What I have done left to the A is clear to everybody. I have drawn a section on the right hand side of Lala. एक मिनट बेटा होल्ड अ सेकंड hello I have drawn a section at the right side of the A. I have written over here right to the A. I have written right to the A. That means what are the different forces acting on the left hand side? We are always looking for the left hand side. Huh? Only RA is there. So RA, what is the magnitude of RA? Magnitude of RA is equals to W by 2. That is, we have calculated over here. Now, I am moving that towards the left of the C. I have shifted that section to the left of the C. What are the different forces on the left of the C? There is only RA. So I have written over CLA. I can write over here as this. So left to the C, the same. Now I have to write or I have to calculate right to the C forces. So I have shifted that section to the right hand side. Again, I am looking towards the left hand side. So what are the forces? RA is there and W is there. So I am going to write here as a RA minus W. Why I have written RA minus W? because RA is going upward and W is going downward. So RA plus W minus. So what is RA? RA is W by 2 and the W is as it is. So W by 2 minus W, it is a minus W by 2. Minus W by 2. Then I'm shifting this to the left hand side of the B. Again only R and W is there. The answer will be the same. W by minus W by 2. And again I'm going to shift this towards the left of the P. There is nothing. Addition of all the forces will be 0. So RA plus RB, RA plus RB minus W, there will be 0. Okay. I guess everybody come to know the calculations. If any doubt, any query, ask me right now. If any doubt, any query, if left of the A is equals to left of the B is equals to 0, in that case, whatever the calculation you have done is perfectly correct. If any doubt, query, please ask me. If any doubt, query in this regard, ask me. If any doubt, query, please ask me. There is no. I have to ask to everybody. Huh? Number one, Ahir Abhijit.
Yes, sir.
Any problem?
No, sir.
Bagulom,
No, sir.
Nikam Pratik,
No, sir.
Sheetal Jagtap. Sheetal Jagtap, are you there or not?
Yes, sir.
Understood? Understood?
Yes.
Okay, Sonu Samsare.
No, sir.
No doubt, or you are not getting anything.
No, sir.
No means yes, no means what? You are getting anything or you are not getting anything. Understood?
Yes, sir.
Good. Anjali Sant.
Clear, sir.
Great. Diva Ahire.
Yes, sir.
Clear na?
Yes.
Kalpesh Patil.
Yes, sir.
Any doubt?
No, sir.
Kalyani Chavan.
Yes, sir.
Any doubt?
No, sir.
Krishna Nikam.
Yes, sir.
Any doubt?
No, sir.
Nilesh Kuwar.
Yes, sir.
Any doubt? Nutan Katswe.
Yes, sir.
Any doubt?
No, sir.
Rani Gholop.
Yes, sir.
Any doubt?
No.
Sahil Dangi.
No doubt, sir.
Saurabh Javre.
Yes, sir.
Any doubt?
No, sir.
Okay, great. Now I have done second step. Second step of shear force calculation. Now I am moving toward the third step, that is bending moment calculation. Bending moment at the extreme end of the simply supported beam is always equal to 0. Don't think about anything. Just mention as simply supported beam at the extreme end there is a bending moment is always equal to 0. So bending moment at A is equal to bending moment at B is equal to 0. Bending moment at A equal to 0. Bending moment at B is equal to 0. Now we have to calculate the bending moment at point C. So RA into C, RA into L by 2 is a bending moment at C. RA into L by 2 is the bending moment at C. Force into distance is nothing but the bending moment. RA into L by 2 the. We are just focus here. It is the word is bending moment at C. Yeah? It is not a summation of moment at point C. If it is said to be a summation of moment, in that case we have to focus on RA and RB both. But here it is we are calculating bending moment, so we have to focus on the forces acting on the left hand side or right hand side. Okay, so bending moment at C is a RA into L by 2. So RA is a W by 2 and L by 2 is the distance, so it is WL by 4. Clear? So the step number 3 is clear. The step number 4 is draw shear force diagram. So how to draw shear force diagram? Come back to here. This is your loading diagram. This is your freeboard diagram. We have to extend each and every point, and we have to draw the shear force diagram. It is A point. RA is W by 2. So we are considering a W by 2 as a length, and we are just drawing upward. So for that drawing, there is a table. I'll give you the table for drawing. Right now, I'm not telling you how to draw the shear force and bending moment diagram, because for different loading there are the different. There's a parabolic curve. There's a inclined line. There's a vertical line. There's a different types of the lines are there, lines and curves are there. So right now just focus on the calculation. In the next lecture, I'll give you the table for the sign convention for which type of the load is there. In that case, which type of the curve is to be drawn, which type of the line is to be drawn. So that is step number. Today we have seen SF calculation, that is reaction calculation, SF calculation, and the bending moment calculation. I will tell you how to draw shear force diagram and bending moment diagram in the next lecture. Now it is 12:35. If anybody of if anyone has any doubt, any query, you may can tell me. Else, if you have given the attendance, you may can leave the classroom. No issue. Anybody is willing to talk to me, you may can. If you have no any doubts, you may can leave the session, because there are some guests I have to entertain them.